Hello children, in this lecture we will discuss periodic properties of an atom in detail. Okay children, so one by one we will discuss all the important periodic properties which are given here. So the first is atomic radius, and according to definition, it is the distance between the center of the nucleus and the outermost shell of the atom. Okay children, so distance, this is the nucleus of any atom and these are the shells around the nucleus. So distance from the center of the nucleus to the outermost shell, okay, this distance will be known as atomic radius, as it is shown here in this diagram also. So this is the center of the nucleus and there are two shells. So the distance from the center of the nucleus to the outermost shell, this distance will be known as atomic radius. Okay children, come to next page for detailing of this property of the atoms. Atomic radius, here heading is atomic size. So as you all know that if any atom is having greater value of atomic radius, means its atomic size will also large. Okay, so in short you can say that atomic radius of an atom is directly proportional to atomic size. Okay children, so as far as radius of the atom will increase, its atomic size will also increase. So here the term atomic size, the distance between the center of the nucleus of an atom and its outermost shell. Okay, so this distance is known as atomic radius, and as atomic radius increases, atomic size will also increase. Okay children, so here it is given atomic radius. This is the outermost shell, center of the nucleus, and the distance from center of the nucleus to the outermost shell is the atomic radius. Okay children, unit of atomic radius, it is measured in angstrom unit. Okay, angstrom unit, and represented by A naught. So as you can see here, atomic radius determines bond length. Okay children, so if any two atoms which are bonded together having a lesser atomic radius, then their bond length will be also less, and if related atoms are having higher value of atomic radius, then their bond length will be also high. Okay children, so in short we can say that atomic radius determines bond length. Okay, so greater the atomic radius, larger will be the bond length. Okay children, then next is factors which affect the atomic size or atomic radius. So first is number of shells. Number of shells increases, atomic size increases, or you can say atomic radius increases. Okay, reason: number of shells increases, the distance of the outermost shell from the nucleus increases. So for example, if you take sodium and potassium, so sodium, this is the nucleus of the sodium, and you know that sodium is having 3 shells, and this is the nucleus of potassium, and potassium is having 4 shells. Okay, so the distance in this potassium from center to the outermost shell will be greater than the distance from center to the outermost shell in the case of sodium. Why? Because sodium is having just 3 shells and potassium is having 4 shells. Okay, so as far as number of shells will increase, atomic size or atomic radius also increase. The next is nuclear charge. Nuclear charge increases, atomic size decreases. Okay, so nuclear charge is inversely proportional to atomic size, or you can say that electronic charge is directly proportional to atomic size, okay, or atomic radius. So nuclear charge is inversely proportional to atomic size or atomic radius, whereas electronic charge is directly proportional to atomic size or atomic radius. Okay children, so as you know that in any neutral atom, nucleus and the electrons which are present in the shells are having constant interparticle attraction. Electrons attract nucleus towards itself and nucleus attracts electrons towards itself. Okay, so if nucleus is comparatively having a greater amount of charge, then it will attract electrons towards itself more tightly, and that is why atomic radius of the such type of atom will be shorter. Okay, and if the condition is opposite, means charge of nucleus is comparatively less and electronic charge is greater, then electrons will try to move towards the periphery. Okay, and that is why atomic size or atomic radius will expand. Okay, so such atoms where nuclear charge is dominating, atomic size is less, and where electronic charge is dominating, atomic size is more. Okay children, then nuclear charge of an atom is the positive charge on the nucleus of an atom. Okay, so the charges which are present in the nucleus are positive in nature, because you know that two types of particles are present in nucleus. One protons and second neutrons. Neutrons are neutral particle and protons are positively charged particles. So overall the charge of nucleus will be depend on the charge of protons, and that is why nucleus is a positive portion of the atom. Okay, so nuclear charge of an atom is the positive charge or total charge of proton. Okay, it is equivalent to the atomic number of the element, atomic number Z. Okay, because Z equals to atomic number, and which is Z means atomic number, and atomic number of an atom equals to number of protons present in nucleus. Then third heading is trends in atomic size. So what is the trend in atomic size? Across a period from left to right, atomic radius across the period from left to right, number of shells remains same. So atomic size is unaffected, but nuclear charge increases, and that is why atomic size decreases. Okay children, so overall what is the trend of the atomic radius or atomic size in the periodic table in the period from left to right? In the period it decreases. Okay children, so according to the first point, because in a period all the elements are having same number of shells, and that is why their atomic size should be same, unaffected. But as we move from left to right in the period, nuclear charge increases, and that is why atomic size decreases, because I have already explained you that nuclear charge is inversely proportional to atomic size. So if nuclear charge will increase, atomic size will decrease. Okay children, so as you can see here, in the periodic table, in the third period, if you move from sodium to chlorine in the third period, atomic size will decrease. Okay children, it means that sodium with highest atomic size and chlorine with lowest atomic size. Okay children, then second trend is in period 2, lithium has the largest atomic radius and fluorine the smallest, because fluorine is placed to the rightmost side of the periodic table in halogen group. Okay, neon has a larger atomic radius since in inert gases the outer shell is completely filled, resulting in a force of repulsion. So there is an exception. Neon is placed in 0 group, rightmost place in the period, but its atomic size is comparatively larger because it is having complete outermost shell, and that is why there is a force of repulsion among the electrons and their size becomes larger. So the effect of the nuclear pull over the valence shell electrons is not seen. Okay children, here is a very important point. A cation is always smaller than the parent neutral atom. Since the remaining electrons in the cation are strongly affected or attracted by the nucleus, so decreasing the cation size. Okay children, so means that if you are having sodium ion and sodium atom, so the atomic size or atomic radius of the sodium atom will be larger than its cation. Okay, because this cation is formed after the loss of one electron. So due to loss of electron, overall nuclear charge on the electron in this cation will be comparatively larger than this sodium neutral atom. So overall atomic size or atomic radius will decrease here. Okay children, so always keep in your mind that size of neutral atom will be always greater than its positive ion, and same way size of negative ion will be always larger than its related neutral atom, as for in the case of chlorine and chloride ion. So chloride ion will have larger radius or size than the chlorine atom. And if you are going to compare such cations in which one is having less positive charge and the second is having comparatively higher positive charge. For example, in ferrous and ferric. So ferrous is carrying 2 unit positive charge and ferric is carrying 3 unit positive charge. Okay, so you know that this ferrous will be formed due to the loss of 2 electron, and this ferric will be formed due to the loss of 3 electrons. So due to the higher number of loss of electron here, the nuclear charge will be higher here in this case. So the size of this ion, ferric ion, will be smaller than the ferrous ion. Okay children, so in this way you can explain the radius of positive and negative ions. So what is our conclusion here? We can conclude that atomic size or atomic radius decreases across a period from left to right. Then trend in atomic size down a group. So when we move from up to down in any group, let example in this first group, then atomic size will increase from up to down in the group. Okay, so values of atomic size are given here. You can see with the help of these values also. So when we move in a group from up to down, number of shells increases, and due to increase in number of shells, atomic size will also increase. Okay, because new shells added with increasing atomic number. Okay, so atomic number increase होगा ना, न्यू शेल्स ऐड होंगी, और न्यू शेल्स ऐड होने के साथ एटॉमिक साइज या रेडियस भी इंक्रीज होगा. देन सेकेंड पॉइंट, न्यूक्लियर चार्ज इंक्रीजेज. तो न्यूक्लियर चार्ज भी अप टू डाउन इंक्रीज होता है, बट एटॉमिक साइज ड्यू टू increase in nuclear charge, atomic size should decrease. Okay, but increase in number of shells dominates over increase in nuclear charge, and that is why overall atomic radius or atomic size increases in a group from up to down. Okay children, so this was the first property, atomic radius. In next lecture we will discuss next property. Thank you very much.